Hello everyone, nice to have you here for the third session of this series of webinars covering all the spectral range between 400 and 12,000 nanometers. Here we are going to focus on the shortwave infrared between 1000 and 2500 nanometers. First about myself, you already know me already from the previous ones, but just for the newcomers, I am Mathieu Marmion, working at Specim for more than 12 years now, and now I'm working as a lead application specialist. And I will be really delighted to be your host for this one. First, about the agenda. The Specim company introduction, so that you know actually who we are, what is hyperspectral imaging and the SWIR spectral range, which application benefits from the SWIR spectral range, Specim's offering for this spectral range, and also some discussions I will be only myself, about illumination requirement. And finally, I will be here standing for your question and answers. First, about Specim. Specim today employ about 90 employees, and they are all located in different places. The headquarters is in Oulu, Finland, and we have also some employees in Europe, Barcelona and Munich, also in the United States and also in China. The company has been created in 1995 and is actually a spin-off of VTT, the Finnish National Research Center. And here we make hyperspectral imaging easy. This is our motivation. What is SWIR hyperspectral imaging? So first, before to say SWIR, let's say hyperspectral imaging in general. You take an image, and instead of having normally 3 bands, as when you are going on holidays, you will have more than hundreds. And for each pixel, you can have some spectrum, some spectral information. So spectral imaging is a combination of spatial and spectral information. From the spectral information, you can retrieve some information about your samples, what they are, qualitative, quantitative analysis as well. But then you can have also the spatial information, so you can see the distribution or the place of this something. So hyperspectral imaging, it is that, a combination of spatial information with the spectroscopic information. Now we are going to speak about the SWIR spectral range, and here I would like to highlight that at Specim by SWIR we mean between 1000 and 2500 nanometers shortwave infrared. For many people it stops at 1700. No, for Specim it is 2500 nanometers. And here you can see that you have some very important spectral information which relates here to the SWIR spectral range. If you look at this table, it shows that for different molecular bonds, you have some absorptions at different wavelengths. And here, with the SWIR spectral range, you can have access to protein, to moisture, to sugar, different things as well, which are more like CH3, CH2 bands. So here you can really see the chemical composition of what you are looking at. Applications that can benefit from SWIR spectral region are actually numerous, there are many. We will speak about geology, agriculture, environmental monitoring, waste and recycling, food, safety, security, bit of art and pharmaceutics. The first one we're going to speak about, it is geology. Here you can see this chart, which has been provided actually by Dr. Phil Harris from Geospectral Imaging. It shows that for different minerals, different spectral range, VNIR, SWIR, and thermal infrared are very suitable to really source the different type of minerals and ores. And as you can see, the SWIR is a good spectral range, is a good spectral region for many of them. It is almost, I would say, the mandatory spectral range, spectral camera you need to have for geological application. And here you can see some example for core logging application when you want to make some high resolution mapping of minerals like this. You can see on the left-hand side the VNIR, on the right-hand side the long-wave infrared, but also the short-wave infrared, the one at the middle, where you can see like these different type of minerals, and those can be mapped with a high spatial resolution as well. Keep in mind that the SWIR spectral camera could be used also for airborne application. And here you can see a map processed and obtained via the help of Spectral Atlas to see the distribution of all those minerals. You can see them here. I will not go into details, but we have many of them. And here again, with Spectral library which has been built, it's possible to go with identification as fingerprint would do with human. Also, not only you can make identification of mineral, but you can also look at their crystallinity. So for example, here with the halide, you can make a mapping of the crystallinity which can help you to understand better the metamorphosis phases on which the mineral was created. I'm not an expert, I'm not a geologist myself, so I will not go too much into the detail here, but you geologists who are actually taking part of this webinar, I'm sure you can appreciate the value of this data. Also, it is possible to look at the chemistry of, for example, different types of minerals, so like here the halide, so you can see it could be phengitic, muscovitic, or paragonitic. So here, very names that I'm not an expert again to go through, but here again you can see that the molecular structure can be identified. For environmental use, the SWIR camera is actually really important. Well, it could be used, for example, to inspect microplastics, which are in the ocean or in different type of, like sediment, but also it could be used to detect or to investigate oil spill and how it spread over an area. And here it is an example where our old ISA dual, which was composed of an eagle and an hawk, which is nowadays like our phoenix, covering the full spectral range between 400 and 2,500 nanometers, it is possible to see the mapping of the oil, and that was in the Gulf of Mexico when there was a deep water horizon spillage. So here our technology was used for that. Also, the SWIR spectral range is very useful for art inspection. When we see a painting, it's always nice, you see the color, but you do not necessarily see the work that the artist has made before. So with the SWIR camera, first of all, you can see the underdrawing. That's interesting. But this is not the point of this slide. The point of this slide was to look at a tapestry, a work, which has been made by people, by hand, and they were sewing different types of fabrics. So here, on the left-hand side, you can see how the tapestry looks like nowadays. And they were intriguing. They were looking which type of yarn was used, which kind of fabric was used to make the tapestry. Was it made of silk? Was it made of wool? Was it made of cotton? So here, with the SWIR camera, since you can really investigate the chemical structure, the chemical composition of what you are seeing, it was possible to make a mapping of which type of fabric was used where, which type of yarns. And here it's possible, as you can see, to make a mapping where the silk was located as well as the wool. So silk was in white and the rest was wool. Another type of application where SWIR is really beneficial is to investigate asbestos in concrete. Here it was a university in Roma who actually used our SWIR camera to investigate the different type of asbestos. You can find different type of concrete. And here you can see 4 different type of asbestos, and they could be mapped pretty accurately, again, with the SWIR spectral camera, because, again, the molecule's composition is not exactly the same one. So, again, asbestos could be separated and also, mapped. One thing you have to keep in mind is that asbestos are always very small particles. Having said that, with the SWIR camera, it's possible to use our OLS macro, which is a lens to give you a spatial resolution, or let's say pixel size of 24 micron. Another type of application where SWIR is really an asset, it is related to military, and here it was for the detection of camouflage and targets. So, typically military equipment, they are green, they are brown to match with the landscape, a bit to make like a chameleon will do. But here, when you have the color, you do not really, mimic the material. So, the point of hyperspectral imaging and with the SWIR camera is not really to take abstraction of the color, but to look at the material only, and here different type of camouflage material, even if with your eye you cannot see them, with the SWIR camera actually you could. And here we have many customers either designing fabric for military or to find like this some potential target, they are using the SWIR hyperspectral camera. And it could be used as well to detect explosives, like on the left-hand side of this picture, you could see that some explosive has been put on a wall. And again, here it could be nicely detected with the SWIR spectral camera. or it could be like from airborne application. You can see, you can map really nicely different type of soil, and when something has been buried, when the soil has been disturbed because an explosive has been buried, then it's possible to see it. It's like an anomaly detection. So for landmine detection, the SWIR camera is also really useful. Another type of application where the SWIR spectral range is very important is related to the vegetation. And I really like the slide here that has been provided by Uwe Rascher from the Jülich Research Center. You can see that here, a full spectrum between 400 and 2,500 nanometers, and you can see how the spectrum is affected depending on the level of the chlorophyll, especially around 500, 600 nanometers, but also with the water content of the plant, which is more, between 970 and 2,500 nanometers. So, with the SWIR spectral range, you can really monitor the health of a plant, if it has any lack of nutrient or something, and if it has any pest or something like this. So the SWIR spectral range is also very useful for that. Not only the VNI one, but very often they are combined together. In the food industry, the SWIR hyperspectral camera is also very, very important and used to detect different types of contaminant, and part of the contaminant could be fungus. So here, it was actually a research center in Belgium, we specialized in cereals. They were using the SWIR camera to detect, for example, fungus like ergot. Ergot is a fungus with a really high toxicity, and according to the law, it should be in a concentration less than 0.1%, for instance, on wheat. So here, actually 0.1% for the food for the animals on feeds, but then I think it was 0.01% for human food. Anyway, here again, the fungus has a spectral signature which is different from his carrier, for example, the wheat, especially around 2,200 nanometers and also 1,700 nanometers. Here you can see it in black. So here again, the SWIR camera could be used for this type of application and also to improve processes. So now we are talking about glue detection. That was an application that I tested myself. So basically I had two carriers, I had some cardboard, I had some rubber, and I put it on it three types of glue that I measure at T0 and T plus 3 hours. And then I wanted to see the mapping. And here, with the PCA, you can already see that with the SWIR camera, you can identify where the glue was put, but also you can see if it was wet or dry. So the top, it is when it is dry, at the bottom, when it is wet. Same for the cardboard, same for the rubber. And again, it was possible to make a model, and the identification of the glue and its stage is also possible to be mapped with the SWIR camera. So for process optimization, when there is gluing involved, the SWIR camera can be used. Again, back to the food. Here it was about food quality. Lipid, sugar, moisture, all those three components, which are really crucial for the food industry, could be mapped with a spectral range 1,000 to 2,500 nanometers. So here you can see on those different types of food products, the fat, the sugar, and the moisture could be mapped, as you can see here, with more or less low and high concentration. So again, application with the SWIR spectral range is very useful. The last one, it is about plastic sortings. Here again, most of our integrators are using our FX17 between 900 and 1700 to sort different types of plastics. But again, we would like to show this slide to show that with the SWIR camera, all the plastic can be really nicely sorted. All if they are not black. If they are black, you need to join our next webinar about the FX50. But still, if the plastic are not black, the SWIR camera is actually useful, and it's what I was explaining for microplastic inspection. This is actually a really good camera for this. So I'm over with the application. I'm sure there in the Q&A they will have more questions about it, but so now I will focus about the offering from Specim for this spectral range. The SWIR camera is our camera between 1,000 and 2,500 nanometers. We have made a short video about the SWIR camera actually mounted on our 40x20 scanner. Here you can look at it. And here you can see our SWIR camera here mounted on our lab scanner, which is a perfect setup to measure sample in your laboratory. It is called the 40 by 20 scanner because actually it can take samples as large as 40 by 20 centimeters. Here I have a geological samples. You can see that on this setup you have the illumination included and also the possibility to adjust the height of the camera like this. Notice that this SWIR camera between 1000 and 2500 nanometers, in that not only the detector is temperature stabilized, but also the optics to ensure a constant radiometric behavior of the camera, because even if it's not within the thermal range, still above 2000 nanometers, temperature variation may have an impact on the dark current of the sensors. That's why we have also the optics, which is temperature stabilized. If you want to use it in a laboratory and you can take the dark and the white reference all the time, you also have the possibility to use this instead of the full casing here. Be aware that with this camera you can also use a macro lens. Here you can get images with a pixel size of 24 microns. This macro lens could be used with the FX17 as well. Now, when you want to use this device on this setup, it's pretty simple. We have our acquisition software, Lumo Scanner. When everything is adjusted, you just need to press record, and then the dark reference is taken automatically, then the white, and then finally the samples. We have a second product actually for this spectral range, which is a Phoenix. Phoenix covers the full spectral range from 400 to 2500 nanometers, meaning encompassing also the SWIR spectral range. So it has 384 spatial pixels for the both channels. You have the VNIR and the SWIR channel, and still they are merged optically. Spectral resolution depends on the spectral range, spectral zone, 3.5 or 10 nanometers with different SNR. It could be used for 100 frames per second. This product has been developed mostly for airborne application, but it could be used as well for our SWIR rock for geological application. And here you could see how an installation looks like. So you can see side by side a Phoenix to record spectra between 400 and 2500 nanometers, as well as an OWL, which is a thermal camera to record spectra between 8 and 12 micrometers. The accessories. As you know, the SWIR camera is a camera which is a line scan device. So if you want to use it in a laboratory, you need to use it with a scanner. So we have the 40 by 20 scanner, which is suitable to put samples as large as 40 by 20 centimeters, and it includes already the halogen. So it is like a tabletop system ready to be used. We also have the bigger scanner, 100 by 50, and here on this image you can see this is actually a Phoenix camera, which is placed on it. So here you can put samples as large as 100 by 50 centimeters. And finally, if you want to work in the field, you can put the camera on a rotary scanner. The camera will look sideways, like I'm doing now, clack, and then rotating like this, you can record the scene of your interest. We also have our system for geological application, dedicated for geological application. We have two. We have the SWIR rock, in which up to 3 cameras could be put. And then we also have the SWIR single core scanner, only 1 camera, and here only 1 core at a time could be measured. With the SWIR rock, you could put a full box of core and they could be measured. So those systems are compatible with the SWIR camera, the SWIR rock also with the Phoenix. Also, data needs to be opened and analyzed. And as you know, we have a data processing software which is called Insight. Here with this software, you will be able to look at the spectra, to make some model, to try to make some principal component analysis, to really go through your data and to get the most of it. We also have the Lumo family software, which is more dedicated for data acquisition, which could be used with a camera only, but also with accessories like the scanner. I would like to speak about something which is crucial and very important for hyperspectral imaging is the illumination. You know, like when you do hyperspectral imaging, you measure the reflected light compared to the incoming one. So basically, illumination plays a really crucial role. For this spectral range, basically, there are not so many choices anymore. Halogen, they provide a good and continuous illumination between 400 and 2500 nanometers. It's fine, the spectrum is good. The only con is that you have to be careful with the heat, the lifetime, and you need to focus a little bit. Okay, then the laser. We have what we call supercontinuum laser. Personally, I tested one and the illumination was going up to 2350 nanometers. That was pretty good. The only thing you have to be careful is like when you deal with a laser, it's a class 4 laser, so you need to have some safety around. Then the sunlight, when you want to work outside or when you want to work, for example, for remote sensing application, sunlight is important, and here it can provide good illumination between 1000 and 2500 nanometers, keeping in mind that you have water absorption band in the atmosphere. And here we have been putting LEDs and nothing because, to the best of my knowledge, I haven't seen neither tested any LED up to 2500 nanometers. I have tested some up to 1650, but not 2500 nanometers. So here we put it blank, but I just would like to highlight like it's on purpose, it's just that we haven't found any suitable. Anyway, so here is a summary slide about why you would choose to use hyperspectral imaging. It's a non-invasive and non-destructive method, so you don't destroy your sample, you don't touch it. You can replace manual and visual inspection by having something which is more like a metric, more like objective. It can replace time-consuming lab test because you can measure a lot of spectra at the same time, not like a point spectrometers. You can make also real-time inspections, meaning it could be placed at the top of a conveyor. Cover 100% of the product stream, meaning that you don't need to take something and to measure it offline or at line, as we say. So it's here like 100% inspection. It improves chemical grading. If you think about the food industry, you can really make an accurate mapping of the different property of your food, the salt, the sugar, and so on. Close to 100% accuracy, meaning that chemometry, of course, you cannot give 100% accuracy result, but still you can be close to 95, 99%. Detect a range of characteristics simultaneously, and here thanks to chemometrics, because you can measure and identify different parameters at the same time, and limitless amount of application, where, you know, I'm working as an application specialist and there is no single day where I'm working with the same application. So it's really endless. Anyway, thank you very much. Soon there will be a Q&A. If you want to contact us, if you want to make a measurement, measure some samples, arrange a demo or ask for a quote, please go to our website, www.specim.com, or you can send an email as well to info@specim.com. Don't miss our next webinar. So today we are doing the one with the SWIR camera. In January 18th, there will be the one for the MWIR spectral range, and after that the one with the long wave infrared, but still need to be defined about the date. Thank you. Now I'm ready to answer your questions. So we are back. We are back online for the Q&A. I hope you enjoyed like this the presentation. So we have got already some questions, so they are here on my panel, so you will see me reading them. So let's go through. Can we use the SWIR sensor for satellite as well? Well, the camera hasn't been designed really for this type of environment, because if you want to put it in a satellite, there will be some vibrations. There will be issues as well, you know, with the temperature, because on one side, if you are like under the sunlight or not, I mean, it's going to be hot, it's going to be cold. There will be vacuum. Also, the camera is having a high power, like 150 watts, so it's not designed for being used in satellite. So I would not recommend to use that one for this type of environment. Thanks for the presentation, you're welcome. Can the SWIR camera separate glass from other material in waste? Well, basically the SWIR camera can separate different type of plastics, different type of material, like the FX17 was able to do. So you can think about wood, you could think about stones, bricks, you could think about different type of plastics, paper, cardboard, glass. I have to say that for glass, typically the best camera is more like the FX10, which is between 400 and 1000 nanometers. I have tested as well pyroceramic glass, like you know you put in your oven. FX50 is good for that as well. I do not recall that SWIR was the best camera for that, but so yeah, it can be used like for a single stream of waste. It could be used for that. This is true, or like construction waste as well, where you have a stream with a lot of different type of waste. But for glass especially, this is not the one I would use. I would use better the FX10. Why not to add FX25 of your FX series? That's a good question. The range not covers the 17 to 32, okay. Is it because becoming more popular or sensor cannot be more made cheaply? Well, I have to say, like, we could not find suitable sensors because this is a spectral range like we have already, you know, between 1000 and 2500 nanometers. So we could make a FX version of the SWIR camera, but still, we did not find affordable sensors. We have some competitors who has a SWIR camera up with 640 spatial pixels. We tested that as well, but again, it's not cheap. And secondly, the SNR is not as good as with the version with 384 pixels. So we decided not to go that way because we did not find the suitable, you know, material to do it. But that's something we are monitoring constantly. So maybe in the future there will be, but I cannot say when. And you know, there is our competition looking as well. So hello guys. Is this camera suitable for 3 meter per second conveyor system? Yes, because the question that you need to ask is more like what is the resolution, spatially speaking, you need to have. So this camera can be used up to 450 frames per second. It's not as fast as our FX cameras, but the FX50 you will see like in the next webinar is a bit slower, but still. So the question is more like when you have the belt which is moving, then you have the camera which is acquiring line like this, you know. So then the question is more what is the distance you can afford to have between the lines which are acquired, and then it gives you the answer yes or no. It could be used with a 3 meter per second belt. So this is here that you need to wonder about. Okay, during your presentation you mentioned about alteration of soil can be detected. I was wondering how deep the SWIR camera can penetrate the soil, and do you have an example of application to study soil, organic compound? So, typically hyperspectral imaging, you know, this is a surface measurement method. So you need to look only at the surface of something if you want to see inside. You need to work in transmission, or then you need to have a media which is quite transparent. With the soil, unfortunately, this is quite opaque in that respect, so you can see only the surface. You cannot really penetrate more than a millimeter or even less than that. So we are talking really about surface measurements, so that's why we can see if it has been disturbed or not. And then about your question, if we had actually some research made with our SWIR camera for like different type of soil and organic compounds, yes, we had a customer, an academic customer in Israel. I think it was the University of Tel Aviv, and they were using our SWIR camera like this for soil analysis. Yeah, so it's possible to do. With halogen bulbs being phased out, what is the plan for illumination going forward? For the SWIR spectral range, this is actually a difficult question. Having said that, there is a ban, indeed, for within AU about the halogens, but there are some exceptions. And when you are dealing with laboratory instrument, or when you are dealing with spectroscopy, you are still allowed to buy halogen. The question is, what is offering? This is true, you have less and less manufacturers who are willing, put it that way, to make halogen bulbs because they know that the market has been decreasing a lot. Anyway, you can still find some. The alternatives, it's difficult because LEDs, I haven't seen any. Supercontinuum laser, I have seen, but then is what I was explaining, you know, it's class 4 laser, you need to have like safety instruction to use those. So at the date of today, I'm afraid to say that it's only the SWIR which is the most affordable and maybe the best suited. Will the SWIR camera be useful for identifying which chemicals are released from overheated plastics? All right, I never tried that, but just talking like this about overheated plastics come to me more like camera like FX50, which is really responsive to a lot of gases, which is really responsive for the black plastic, for example. And when you overheat some plastic, basically they can be working in emission. And if you work in emission, I would consider like thermal emission, for example, with FX50 or even like long wave infrared. So for this type of application, I will go more for like longer wavelengths, which do not require to have sample as hot as if you will be with a shortwave infrared. So I think I will go better for like the next webinar for that, like for the FX50. About the 3 meter per second belt. The distance that we want to detect is 5 millimeter. So basically, okay, so then you take the 3 meter per second, which is the speed of your belt, and you divide basically by 450. So it gives you like 3 meter per second. It says like you have about, so it means that here you have about 75 millimeter between each of the line, about. So here it's going to be a bit tricky. So you need to have a camera which is faster, or you need to have the belt which is a bit slower. Is there a specific source where to find case studies to specific application? Yes. So if you go to our website, we have a part which is, if I recall well, a blog or library, and there you can find actually different type of application studies that we have made, and there they are available. Also, if you have some question about some specific application, you can always contact us at info@specim.com, and here we will be really happy to answer your question and try to guide you within your application. I'm still thinking about the halogen question, like what will be available. Yeah, that's a good point. This is something like all of us in the world of hyperspectral imaging, we are wondering how to supply still those halogen. But yeah, we still have we have a stock still, so nothing to worry about it. We got some more questions. Do you know if it's possible to create some sort of custom jig or lens to create sort of telescope to measure something far away? Well, the first question is what is far away? So we are talking about telescope, so it could be something in space. It's always possible to use lens with a really long focal length so that you can have a narrow field of view. At Specim, for instance, we have a lens which is 12 degrees, so I don't know if it's what you mean by far away, but I think it's possible to find even some optical suppliers, Tor Labs, Edmond Optics, and there are some other ones as well. So it might be possible to ask from them if they have a SWIR lens, and really when you ask about SWIR, be accurate mentioning it is 1,000, 2,500 nanometers. And here there might be the possibility to get some lens like this. We don't have for telescopic use, but you may ask different type of supplier. They may have something. Our camera is a C-mount camera, so here you can put whatever C-mount lens, which is matching with the spectral range. Can I increase the frame rate if I reduce the region of interest? Here we have someone apparently has been using in the past our FX10 or FX17. With the SWIR camera, no, we don't have this possibility. It is like the detector which is made that way. So it is 1,000, 2,500 nanometers. And no, you don't have the possibility to make ROIs or multi-ROIs or things like this to increase the frame rate. So that, it's not an FX camera, so it was referring to one of the questions of one of the attendee. So it's not an FX, so you don't have the same features as the FX camera with, as you say, the multi-ROI. So here you cannot do that. So it is 450 max, and that's it. Okay, thanks for your presentation. I would like to ask you about the software. How do you distribute it, and are you going to have any webinar concerning it? Thanks. About the software. So we have, first of all, two types of software. We have the data acquisition software. So this one, it's either part of the delivery or then you need to purchase it separately. That's something to see with the sales manager. And then we have the data processing software, which is called Insight. We have one, and we made actually a webinar about it, and I think Harry just sent the link, so it's perfect. So we made a webinar about it 6 months, a year ago, and then it shows the capability, so you can make regression, qualitative, quantitative analysis, make principal component analysis and things like this. So we have one. We do not distribute it freely, but if you want to have more information, like a quotation, again, you can contact us at info@specim.com, and here we will come back to you with all the necessary information. how to decide which lens, standard macro, is more accurate for application. It's about depth of field. Here you need to contact us. You need to contact us because we have made a technical note which explain, and we have also data sheet which explain. So the different property of each lens and which kind of depth of field you get as well, depending, it depends on the pixel size, it depends on the aperture, it depends on the focal length, the measurement distance. So we have that, and depending on the lens, we can help you, depending on your application and requirement, we can help you. So you contact us, and here we can guide you to tell you, okay, what are the pros and the cons for each of the lenses we can offer. Sorry. I had to have something in the throat. Hello, does SWIR technology allow to identify quartz in natural occurrence? It's a geological application. So as I was explaining, I'm not a geologist myself, but I have heard geologists talking around me, so I know a little bit. For quartz, I understood that it doesn't really have any spectral feature within the SWIR spectral range. The only way that they recognize it is when you have some water, which is somehow included in it. And here, the SWIR camera can identify water. So one way to do is like to monitor water. It's not really a proper way to do that. Typically, quartz is identified with a long-wave infrared, which is a camera between 8 and 12 micrometers. So for quartz, it's better to use the coming webinar. You join us in the coming webinar, maybe in 3 months, something like this. So we're going to have the wave infrared, and this camera is better for this. Have you got experience to part water inclusion in flat still from the normal background? I need to read it again. Have you got experience to part water inclusion in flat stills from the normal background? No, that's something that I don't know, but I'm not sure exactly to fully understand what it means here. So flat still, do you mean like when you have a stack, I guess, and if you have some water at the top of it? That's what I understand. But anyway, so for still industry, typically this is not the SWIR camera which is used, but it is more like the FX50 again, which is really responsive to oil and also for water. But here, just like this, I would say, no, I don't have experience myself. And okay, I have still a short question. Do you have an application using SWIR camera which is not airborne? Yes, so we had the plastics, we had, for example, the soil, we had the glue, we had geology, the core. We had the art analysis with the tapestry or the painting. So yeah, we had actually quite a lot of applications which are not airborne. So do you make spectrograph up to 2500 nanometers? Your webpage has only up to 1700 nanometers. This is true. In the past, we were having also what we call the SWIR spectrogram, which was the N25E, but we decided not to sell it anymore, so it is end of life. So if you're interested by this full spectral range, I recommend you to contact our sales team, info@specim.com, and then they will be able to come back to you with our products that we have for the SWIR spectral range. Application for plastic waste sorting, yes. So as you saw, the SWIR camera could be used to sort different type of plastics. Plastics if they are not black. So if you start to have some black plastics, then you should attend actually the next webinar, which is going to be on the 18th of January, about the FX50, because FX50 can sort plastics regardless of color. But if they are not black, yes, you can use the SWIR camera or the FX17. So if you want to use more for, online application, it's better that if you are using a camera which is really dedicated for online, like FX17 or GX17. This is true that with the SWIR camera you can get better results, but okay, that's it's not really designed for online application. Having said that, related to plastic again, the SWIR camera is really useful for microplastic inspections. Keeping in mind, for example, it could be used with a macro lens. The one I was speaking about, you can get a pixel size of about 24 micron, and there you can really make some nice identifications. Using these techniques, it's possible to detect the black color plastic FX50. FX50 is the one which is needed, so please join us in about a month and a half or 2 months about the next webinar. Can we use SWIR? Do you know application of HSI in the SWIR range in medicine? Yes, in the pharmaceutical industry, in fact, there are quite a lot of ingredients which are having some nice spectral features up to 1700 and up to 2500 nanometers. So typically for pharmaceutics use, the SWIR camera is the one which is preferred. So you can make some inspection, like to check the concentration of the active principal ingredient. You can also measure the quantity. You can measure if you have the right ingredient or not in your pills. You can check your recipe. You can make some research. So yes, the SWIR camera is the right one for that. Actually, we have a customer, this is public. We have one in France called Indatech, which are using our SWIR camera for pharmaceutics use. So, but you can contact us as well. It could be used. Okay. Can we use SWIR camera to detect lithium on core? I have to say here, for the lithium, it is like a metal, and most of the metals are mixed with different type of ore, different type of minerals. And here, this is where the SWIR could be interesting. So just to detect the lithium, it's not very useful, but to detect the ore where it is, it could be useful. And since the SWIR camera is actually the camera which is preferred for most of the geological application, then it could be that this is the right camera for it. Having said that, I'm not sure which of the minerals, in which ones you can find the lithium. But you know, with our Sisu rock, you can use more than one camera because, as you have seen in the presentation, the SWIR camera is good for certain type of rock, the VNIR is good for some other type of rock, and the long-wave infrared is used as well for some other type of rock again. But so it's hard to say which one is the correct one. Here you need to come with more geological information, which are the minerals in which the lithium is located. Which particular SWIR camera model you would recommend? Ours. I would really recommend you to use our camera. We have some competitors, but yeah, I would recommend our camera. So I don't have so much to add on that. Able to scan solid surfaces, desk, wall, car door example to detect chemical agent, residue, indoor, outdoor. Have you come across similar application? Yes, to detect different type of coatings as well. So if you want to make some surface inspection, if you want to detect different type of coating or additives that you could have at the surface, this is true that the SWIR camera is a good camera for that because you can really inspect, the chemical property of what you have as the surface of your object. So in that respect, yes, you can really do that. Sorry, I adjust my microphone, so here's better. So yeah, this is the right camera for that. And we come across similar applications like this. How can SWIR hyperspectral imaging revolutionize precision agriculture practices, and what are the tangible benefits for crop health monitoring and yield optimization? So basically, hyperspectral imaging is used, of course, to monitor crop. And the good thing with hyperspectral imaging is you can really identify peaks, you can see slopes when you have some peaks. So you can really quantify if you have some nitrogen, potassium, or phosphate, different type of stress. And here it could be really useful in a way that first you can detect where to put some ingredient, where to put the fertilizer, and to target in some area. So you cannot just spread everywhere and pollute everything if you have too much. You can also detect if you have disease at the early stage, so before they start to spread in all your crops. So you can think about vineyard, for example. There has been some disease which are really a threat actually for the farmer and for the full crop. So hyperspectral imaging could be a revolution in that way that you could think about more sustainable, the way you manage the fertilizer and all the chemical you are using, so that you don't put too much. You can really target, and when you target where you put your product or where you detect your disease, then you can really improve your crops as well, your yield, because then you have been able to enhance exactly at early stage if there was any issue. Could that wet dry identification be used for the concrete or other construction material? Well, first of all, you have to think that hyperspectral imaging is a surface measurement method. So if you are thinking, for example, of using this camera to monitor the moisture you could have in concrete wall, for example, in the foundation of a house, or if you want to monitor these kind of things, be aware that you will be able to monitor only what you have at the surface. Also, for other material like wood, it is true that you can also monitor the moisture, but again at the surface. So here, you have to make the hypothesis that what you see at the surface is representative of what you want to see inside. And here, I don't have a clear answer to you if it is exactly what you want to see. If you want to see what you have at 20 centimeters inside your concrete or inside your wood beam, no, hyperspectral imaging cannot do that. We are planning to expand our SISU single-core scanner with SWIR. Do you think it is viable range to trace biogenic silica opal? To the best of my knowledge, actually SiO2 refers to quartz. And actually quartz, it is better to identify with the long-wave infrared, meaning like with a camera between 8 and 12 micrometer. Why? Because quartz doesn't have any spectral feature really between 1000 and 2500 nanometers, except the fact that you can have a bit of water in there. So that you can monitor. You can see that you can have the water absorption, but not really specific feature for the quartz. For the quartz, you can have more than, for the long wave infrared. Then if you are talking about silica opal, maybe it's another way of arranging the molecule in there. Here, I'm not sure, but to the best of my knowledge, the silica is better with the long wave infrared. Can it analyze the composition of pigment for forensic art in art application? Yes, it does. And actually, I just had like this afternoon a presentation for the Hyperspectral Summit, which is going to happen soon. And there I'm talking about the nice work made by the National Gallery of Art of Washington. And there they have been able to monitor, first of all, the underdrawing, so this is a well-known application, but also which type of pigment was used. So, for example, they were tracking pigment based on azurite, and there you have a nice absorption peak about 1500 nanometers. So when you try to monitor that with a SWIR camera and you have this peak of absorption at 1500 nanometers, especially, for example, for azurite, but for the other it could be as well, then you have the possibility to use a SWIR camera for that to make an accurate mapping, to make identification of pigment. Not with the color, but more for the recipe of what they are. So yes, it's possible to do that. What about additive content detection in waste plastic? If you are talking, for example, of flame retardant, for example, so yes, it's possible to look at them. Especially, for example, for the brominated ones, it can be seen as well with the FX17, but also with the SWIR camera. I remember, like, just a reminder, like FX17 is between 900 and 1700 nanometers. So yes, it's possible to do. There are some peaks, but having said that, I'm not sure that all additive could be seen, like, for example, glass fibers or different type of things. Some research needs to be done, but yes, for some of them, it is possible. What application do you think is best suited for SWIR in the construction sector? I have seen some application when you want to see if a wall has been renovated, for example. So if you think like you had a building and some part seems to be a little bit different than some others and they are not made of the same concrete, for example, the SWIR camera could be suitable for that. You can detect if the same type of bricks, the same types of cement between the brick has been used. So here the SWIR camera could be used for that. For other things, the construction sector, I could think as well more like it's not really the construction sector, but it's linked. It is like for the firemen when they want to map which type of roof is used, which type of material, is used in the construction for the roof and things like this. Then in order to understand where the fire could spread faster, kind of roof, kind of vegetation, it's a bit drifting away from the question, I have to say, but other than that, no, I don't have any other one for the construction sector. What are the classification algorithms available in Specim inside? PLSDA, and then we can make also principal component analysis. What is the principle of laser illumination at the end? This is a small spot, not large light beam. What is the principle of laser illumination? So basically you can put some optics in front of the, so you have your laser, which is basically giving you a point, but then you can put an optics which is actually transforming the point into a line. And this is what we have been using. I don't remember exactly, I think it's called a Powell lens. Sorry if it's not the right term, but I think it was a Powell lens. And then we were putting that just in front of the output of the laser, and then we obtained a line, and then we're able to use our hyperspectral camera with that line. I use Specim SWIR camera for the plastic sorting application, and the determination of the material is tricky in the case of a glossy surface with high specular reflecting. Are there a way to work around this problem? Yes. So basically you need to use the camera in a specular fashion, not in a diffuse fashion. So basically, typically when you want to measure like reflectance spectra, you have the illumination at about 45 degrees, and then the camera looking at the middle, like you will see my head, for example, here. So light is coming here, and reflection is in every direction, and then, you know, the camera can see it. But in some cases, you cannot do that. So basically, you have the light in a place, and you have the sample which is acting somewhere like a mirror. So you need to have the camera which is in a specular fashion. And here you have the possibility to see, to identify the different type of material. This is the way we use, for example, the FX50 when you have glossy black plastics, and here it's possible to sort them. Notice that in a specular fashion, you can also sort the diffuse sample, not only the glossy ones. What are the mean concentrations necessary to see chemical signals? Relative ratio, I guess, is a better way to ask. I would say this is a really tough question because it depends on the chemical signal you are looking at. Some, they could be very reactive. So for example, if you think about water, water is really reactive for the SWIR spectral range, so you don't need to have a high concentration to be able to see it. But if you have a chemical which is not really reactive, so then you cannot see it. But if I go back to the water, for example, again, you have like a strong absorption about 1,430 nanometers, and you have another one at 970 nanometers. And the one at 970 nanometers is not as strong as the one at 1430 nanometers. So even if it is the same chemical, depending exactly where you are looking at, you don't have the same capability to identify, and so it's a difficult answer here. Would like to know which drone brand is recommended to bind with AFX10, and can it be controlled the trigger via drone output port if there is? So the DJI drone, they are pretty good actually with the AFX10. I have to say this is a little bit out of the SWIR webinar, but it doesn't matter. So the DJI drones, they are a good one, but you could use whatever drone as long as they can carry a payload which is about 2.5 kilograms. So if you can do that, that's okay. Then you can choose to have a fixed mount, you can choose to have a gimbal, it doesn't really matter, and you can just put it there. And about the triggering, the way to do is that with our acquisition software, we have a flight management system in which you can pre-program somehow how the flight line will be done. So you need to match our flight management system with the one of the drone, and then you will have the possibility then like this to tell where to start and where to stop the acquisition and things like this. And this is done automatically. You don't need to have external trigger to do that. Surface. What is the penetration depth? So the penetration depth, that's a good question. It depends again on your samples. You can have some samples on some materials which are really like transmittive towards the SWIR spectral range, and you can have some other ones which are really opaque. So I don't have just an answer like this, but as a rule of thumb, I would say it's maybe 1 millimeter. But again, it can be less, it can be more, it depends on your samples, it depends on the material. We have a Specim IQ VNIR camera. Is it possible for us to use a macro lens with a Specim IQ? If yes, is the macro lens available on your website? No, unfortunately, you cannot use a macro lens because the macro lens, the OLS macro, is only suitable and transmitting the light between 900 and 2500 nanometers. And here it doesn't match with the spectral range of the IQ. So no, unfortunately, you cannot use it with the IQ camera. Okay. Can I get an application note about the inspection of pigment in artwork? Yes, we can do that, or we can put you into contact with some people who have been using our camera and making a lot of artwork. So we have some PowerPoint, we have some publication, but yeah, you can contact us, info@specim.com, and we'll come back to you. What is the recommended reference lamp for FX17? So for FX17, it's between 900 and 1700 nanometers. I would say you just need to use, if you are talking about halogen, you just need to use a halogen lamp which is DC powered. It's always better. And then you can just choose whatever you have. It's better that there is no glass in front of the halogen lamp, but I would say like, yeah, just a halogen, there is no special model. Yes, with power lens it's possible to make spotlight, but laser is one wavelength, not a spectrum. Here I have to say, you have laser, I agree with you, you can have only a specific wavelength, but then I recommend you to have a look at what we call super continuum laser. And for example, you can check those from NKT. Those are pretty good. We tested them, and we tested one with a light between 400 and 2350 nanometers to the best of my memory. And yes, you can get continuous laser over the full spectral range, as I say. They are called super continuum laser. Does your software have specific algorithm for each application, or is it more like general algorithm suitable for any application? This is more the second approach. So basically, we don't have algorithm dedicated, but we have a general one, PLS or PLSDA or ACP, that you, or PCA, sorry, that you can use like this for different type of application. Thanks for the answers on biogenic silica. This is an amorphous SiO2 non-crystalline form. Okay. Then do you think it is possible to mount LV MDVR camera on SPEC? No. On a single core scanner you cannot, because the illumination is not suitable. So here for the single core scanner you can, you have the halogen illumination like the dome, and here you have illumination suitable between 400 and 2500 nanometers. So here you can have an FX10, you can have an FX17, or you can have a SWIR camera, one at a time. If you need to go for thermal illumination, like thermal camera, like FX50 or the coming long-wave infrared, then you need to have what we call the 100 by 50 scanner, on which the thermal illumination can be mounted, and then on which a thermal camera can be mounted. Yes, detect liquid chemical on surface. Yes, it depends on the chemical. For some of them it can work, for some other it can work, it cannot work. It depends as well on the surface as well as the substrate. Does it absorb everything or not? Or yeah, in some cases it works, sometimes it doesn't. So hard to say, but yeah, why not? How average power need on supercontinuum laser as a source? Well, here I would say it depends on many things. It depends on the brightness you want to have. It depends on the spectral range you want to have as well. Here I recommend you to check the one of the manufacturer. We are not making ourselves supercontinuum laser. As I say, this is a source of light that we tested, but I really recommend you to check on internet, to Google. Do you have any example of hyperspectral data compatible with MATLAB? Yes, ours data, they are compatible with MATLAB or with Python. So I would say like 90% of the people doing research, they are using MATLAB or Python with our data. So yeah, the data we are making, they are NV format. It's not a proprietary format from Specim. So here you can use MATLAB without any problem. And there is a question. Are you collaborating with optical detector companies supplying your camera to them? Yeah, of course. We buy our detector from some other company. We don't make the detector ourselves. Yes. So, yes, so sorry, I was at the middle of my conclusion. So yes, thank you. And again, I hope to see you, all of you, on the 18th of January for the next one about mid-wave infrared. And yes, have a nice morning, evening, day, whatever it is. So, bye-bye.